Hello everybody and welcome to the video for the pretest for exam 5. To start out with, I just wanted to talk about the multiple choice, and you might get a question on the exam about choosing the strongest correlation, like number 1. When you do that, please remember that the correlations can only range from -1 to 1. So anything above +1 or below -1 is an impossible value. So knowing that, we could rule out D 1.35 automatically because it's impossible. When you have the rest of the values that are possible values left, then ignore the sign and focus on the size of the number. And I ignore the sign and also the decimal place, and I just kind of focus on the numbers. So here I'd say 43, 70, and 67. 70 is the highest of those three numbers, so the correlation of -0.7 is the strongest correlation here. So that's how I'd run through that. 2, if Pearson's R between variables A and B is calculated to be 0.95, we can confidently report that A, variable B is caused by variable A. B, variable B is probably caused by variable A. C, variable A is caused by variable B. D, none of the above. The correct answer is, of course, none of the above. We talked about do not imply causation from correlation. So anytime you see anything about just based on a correlation, can you determine anything about cause and effect? The answer is no, or none of the above. 3, given that the slope was significantly different from 0, if B is 3 and A is 7, a person scoring X of 15 would have a predicted Y score of A 21, B 52, C 108, or D 317. We would need to use our regression equation formula, which is y hat. Let me go to the document camera maybe now, and I'll just stay here. Okay, so we need to use our regression equation. Let me get my pen. And I'm back. And so y bar is equal, or y hat is equal to A plus bx. And they gave us all these values, so it's really just plug in and solve. A, they gave us a 7. B, they gave us was 3. And X, they gave us a 15. So we just plug those in. It'd be 7 plus 45, or 52. So the correct answer for 3 would be B, 52. That's all you need to do there. 4, the direction of the relationship between variables is indicated by the A, magnitude of the correlation. No. B, A, no. C, y-intercept. Well, that's the same thing as A, so no. And D, slope. Yes. So the direction of the correlation is indicated by the slope. It's also indicated by the sign, negative or positive, associated with the correlation. So either when you see R is negative something, that indicates direction, right? R is positive, that indicates direction, or the slope of the regression equation also indicates direction. 5, restricting the range of either X or the Y variable, A, raises the correlation. No. B, has no effect on the correlation. No. C, lowers the correlation. Yes. D, makes the correlation 0. No. So anytime you restrict the range of either X or Y, it lowers the correlation. Now, I don't have time in this video probably to show you the, like from a previous example that restricting the range lowers the correlation. But if you want to take one of our previous videos and just eliminate like one of the high values for X or Y, you have to eliminate the whole score. So like a good thing for practice might be go back to the example we did on the crime-related TV viewing and the attitudes about the government, and eliminate the person who had 12 hours of crime-related TV viewing, eliminate their X and their Y score, and then recalculate the correlation. You'll find out that the correlation is lower by not having that person in, because when we restrict the range, it lowers the correlation. 6, a high positive correlation is represented by a line that A is horizontal. No. B slopes downward and to the right. No. C slopes upward and to the right. Yes. D is vertical. No. Vertical is a FOIL that won't happen. You're not ever going to have a vertical line. The slope upward and to the right is a positive correlation. If it slopes downward and to the right, that's a negative correlation. And if the slope of the line is horizontal, if the line itself, is horizontal, then it indicates no relationship between the variables. So that's the multiple choice. And then this is sort of one problem left on the practice test that does both correlation and regression. So it kind of brings in together all the things we've done before. So it is commonly recognized that a poor environment, for example, poverty, low education level of parents, and the presence of stressors, for example, divorce of parents, abuse, are associated with lower achievement scores in children. Recent research indicates that a child's achievement score is related to the number of such risk factors in the child's background, regardless of which specific factors are present. Below are the numbers of risk factors in the achievement scores of 9 children. Okay, so they have sort of, this was number 3. And then we didn't have any other one. This is, so I'm just going to put the data here for 7. Child. Of course, we're going to have risk factor, which is going to be our X variable. We're going to need X's squared. We're going to need achievement score, which I'm just going to call achieve. That's our Y variable. We'll have our Y squares, and then we'll have our X times Y column. Okay? The risk factors, well, really children, we had A, B, C, D, E, F, G, H, and I. And the risk factors for child A were 3, B, 6, C, 0, D, 5, E, 1, F, 1, G, 4, H, 10, and I, 4. And then the achievement scores for these children, A was 7, B, 2, C, 15, D, 3, E, 12, F, 11, G, 6, H, 1, and I, 5. All right, so let's go ahead. First of all, we need our N here. 1, 2, 3, 4, 5, 6, 7, 8, 9 children. Risk factors sum up to be total risk factors of the group, 34. Total achievement score, the sum achievement score for the group, 62. X is squared, 3 squared is 9, 6 squared is 36, 0 squared is 0, 5 squared, 25, 1 squared is 1, 1 squared is 1, 4 squared is 16, 10 squared is 100, and 4 squared is 16. So the sum of x squared is equal to the sum of that column, which is 204. Y squared, 7 squared is 49, 2 squared is 4, 15 squared is 225, 3 squared is 9, 12 squared is 144, 11 squared is 121, 6 squared is 36, 1 squared is 1, and 5 squared is 25. So the sum of y squared is the sum of this column, and that is 614. And then sum of x times y, we're going to get by doing those for this last column. 3 times 7 for the first person is 21. 6 times 2 is 12. 0 times 15 is 0. 5 times 3 is 15. 1 times 12 is 12. 1 times 11 is 11. 4 times 6, 24. 10 times 1, 10. 4 times 5, 20. So we need to add all those together. And and we'll get our sum of x times y, which is 125. Okay, so now that we have all our sums, let's do A, draw the scatter plot. Hopefully we have enough room here. We'll make it fit. 15, good. Okay, so 15, okay. 15 is the highest achievement score, so we have 15 of these. Oh, thank goodness. Our y variable, our x variable, okay, 15 and 15. And then B is going to be, based on the scatter plot, do you think stress factors are of achievement, stress factors and achievement are related, positively correlated, negatively correlated, unrelated? So I'll leave room for B there. Okay, so let's plot this data. Risk factor 3 out, 3 up, 7 for the first person. Out 6 up 2. Out 0 up 15. Out 5 up 3. Out 1 up 12. Out 1 up 11. Out 4 up 6. Out 10 up 1. And out 4 up 5. Now, had I drawn these to scale, these would be a little straighter, but pretty clear that this data slopes down and to the right, so negatively correlated. Negatively correlated. So we have A and B. Now we need to start our calculations for the correlation. So let's do this. Calculate SSX is C. SSX is equal to sum of x squared minus n times x bar squared. Okay. Now we didn't do x bars and y bars and x bar squareds, the original data, so I'll have to do them. Actually, let's go back. We have enough room kind of in the middle here. X bar is the sum of the x over n. That's 34 divided by 9. So x bar is 3.78. Y bar is the sum of y over n. That's 62 over 9, which is 6.89. And then x bar squared is 3.78 squared, which is 14.29. And y bar squared is 6.89 squared, which is 47.47. All right, so we have our values on this page this page that we need to plug in to do our calculations. We'll refer back to them. Sum of x squared minus n times x bar squared. Sum of x squared, 204. N, 9, x bar squared, where'd you go? 47.47. So we'll take those. This is 204 minus 9 times 47.47, which is equal to 204 minus 9 times 47.47 is 427.23. And 204 minus 47 point, no, I'm sorry. It's 128.61. I'd have found how I got off on my sheet. I was looking at the sum, the n times y bar squared. This is 128.61. So 204 minus 128.61 is 75.39. And this is a positive number, so that's good because our sums of squares should always be positive. It wouldn't have been. I would have known something was up, but it was this time. SSY is sum of y squared minus n times y bar squared, which is equal to sum of y squared, 614. N was 9, y bar squared, 47.47. So that's where we messed up on the previous one. If you go back to the SSX calculation, I'm sorry, but x bar squared is not 47.47. It was 14.29. And that's why if you take 9 times 14.29, it's 128.61. So a little hiccup there, sorry. But sum of y squared is 614. N is 9, and y bar squared is 47.47. That's 614 minus 9 times 47.47 is 427.23. And that gives us an SSY total of 186.77. So positive, again, good. Now E, calculate SP. Sum of x times y minus n times x bar times y bar. Sum of xy is 125. Pull that from over here. 125. X bar 3.78, y bar 6.89, and n is obviously 9. So 125 minus 9 times 3.78 times 6.89. That's 125 minus the whole sum. 9 times 3.78 times 6.89 is 234.40. 125 minus 234.40 gives us SP. That's negative 109.40. And that's good. SP should be negative because we think there's a negative correlation here. And so we're good to move on. F says, now, if you wanted to go ahead and skip down, you could to I and calculate the correlation coefficient. We've certainly done that in that order on our other videos. I'm just going to stick with the, because it really doesn't matter the order we do these things in. I'm going to stick with the order on the review sheet. The order on the test is more, it follows closer to what order we did on the videos when we practiced this. So F's calculate the slope. So we need B. That's SP over SSX. SP is negative 109.4. SSX was 75.39. So our slope to our regression equation is negative 1.45. And your slope should be negative because the direction of the relationship between these variables is negative. All right, so G, what's the y-intercept? So A is equal to y bar minus B times x bar. Y bar is 6.89. B is negative 1.45. And the x bar is 3.78. So this is 6.89. If we multiply negative 1.45 by 3.78, we're going to get a negative 5.48. But if we subtract a negative, it's the same thing as adding a positive. So I'm just going to say plus 5.48. If you want to do in your calculator, if you want to leave that as a negative, since you multiplied negative 1.45 times 3.78 and got a negative 5.48, that's fine. And you can just subtract a negative from 6.89. When you subtract a negative, though, it's just going to add the points to the 6.89. So 6.89 plus 5.48 is 12.37. So that's our y-intercept. So really quickly, F says when x increases by 1, we think that, so as risk factors go up by 1 extra risk factor, we think that the achievement score is going to go down by 1.45 points. And then G, the y-intercept, says when x is 0, when there are no risk factors, we predict the achievement score to be a 12.37. So that's the interpretation. H, state the regression equation. So the formula is y hat is equal to a plus bx. We need to just plug in our values. So we're plugging our values and state the regression equation. Y hat is equal to, a was negative 1.45 plus b, which was, I'm sorry, a was 12.37. Let me just move all this down. Y hat is equal to 12.37. And because it's a negative 1.45 for B, then instead of plus BX, I'm just going to say minus BX. You could say plus a negative 1.45X if you want. But more correctly, it's 12.37 minus 1.45X. That's the stated regression equation. So been trying to keep track of these for you. The answer I'm looking for there is the stated regression equation here. Okay, with the numbers in. Then I calculate the correlation coefficient, and R observed, which we've been calling it, is equal to SP over the square root of SSX times SSY. SP was up here at E, negative 109.4. That's over the square root of SSX was 75.39 times SSY 186.77. If we multiply 75.39 by 186.77, we get 14,080.59. So 14,080.59. Big number, right? Well, let's take the square root of that and get it back to something a little more manageable. On top, we have negative 109.4. And if we take the square root of 14,080.59, we get 118.66. And if you take negative 109.4 and you divide by 118.66, then your correlation for this, the relationship between these two variables is negative 0.92. So pretty strong negative correlation, right? Very strong negative correlation between these two variables. All right, moving on. Let's do J. Test to see if the slope was significantly different from 0. So right there, they're not saying test the correlation. We don't use the 8 steps of correlation. We use the 8 steps of regression because they said test the slope. So step 1, state the null. Beta is equal to 0. State the alternative for research hypothesis. H1 is beta not equal to 0. 3, state the alpha. Alpha is 0.05. Now, by the way, this is all J up here. 4, what kind of test is it? Regression, F-test. 5, state the assumptions. X and Y are linearly dependent. X and Y are approximately normally distributed. Okay. Step 6. I want to skip a step. Find the critical value and state our decision rule. Okay. Remember, degrees of freedom reg is always 1. Degrees of freedom error, n minus 2. How many total people did we have this time? 9. 9 minus 2 is 7. And df total. Not that you really need it to find the critical value, but we'll need it for our source table. N minus 1, 9 minus 1 is equal to 8. All right, so the critical value, F crit. What is it? Let's go look it up. So here is the table of F values. Our degrees of freedom for the numerator, this, by the way, is page 554 in your textbook. Degrees of freedom for the numerator is 1. That's degrees of freedom regression, right? Is 1. Degrees of freedom for the denominator is error. That is 7. So go down 7 over 1. We've run into this in another example. 5.59 is our degrees of freedom. I mean, that is our F critical, 5.59. And now we can go back to our document camera. See our F critical is 5.59, and we say our decision rule. If F observed is greater than 5.59, reject HO, else accept HO. All right, so all 6 in there. Sorry, my back's hurting. Oh. Step 7, calculate the F. Sums of squares total equals to sums of SSY. SSY, bring it back in just briefly, 186.77. We calculated that in D. 186.77 is our total sums of squares. Sums of squares regression, SS reg, R squared times SSY. R was negative 0.92. We're going to square that value. I got R, remember, from I. It's negative 0.92. We're squaring that, and we're going to multiply it by sums of squares for the Y variable of 186.77. All right, negative 0.92 squared is, what is that? Oh, I want to say, hold on, just give me a second. I shortcutted myself here, so I didn't do myself any favors. 0.92 times 0.92 is 0.85 to 2 decimal places. So it's going to be a positive when we square it, and it's 0.85 times 186.77. So sums of squares regression is 158.75. 158.75. All right. I'm just going to, again, circle these because, or box them in because I want to make sure that you're aware of the values we need for a source table. Sums of squares error is equal to sums of squares total minus sums of squares regression. It's 186.77 minus 158.75, which is equal to 28.02. Okay, we got our sums of squares. With our degrees of freedom, we should be able to get mean squares. Regression, we really don't need to do this calculation because it should just be the same as our sums of squares regression, but let's check. Sums of squares regression over degrees of freedom regression. Sums of squares regression is 158.75 over 1. Yep. 158.75 is our mean squares regression. Okay, mean square error is sums of squares error over degrees of freedom error. Sums of squares error is 28.02, degrees of freedom error 7. 28.02 divided by 7 gives us a mean square error of 4. And then the F observed, I'm try to put it over here so I can put our source table down below. F observed is mean square regression over mean square error. That's equal to 158.75 divided by 4. So our F observed, the big value we were after, is 39.69. So 39.69 is our F. Put our source table down here. Okay, we got our boxes in. We got source, regression, error, and total. Sums of squares, degrees of freedom, mean squares, F. No values in the bottom three, the bottom corner, bottommost right corner, 3 boxes. So let's fill in what we've got. Sums of squares regression. That was 158.75. Sums of squares error, 28.02. And the total, 186.77. Degrees of freedom, regression is always 1. Error is 7 this time. Total is 8. Mean square regression is the same as sums of squares regression, 158.75. Mean square error, we calculated to be 4. And our F total was, F observed was 39.69. So we put that in there. And then 8 to complete the steps, because F observed equals 39.69 is greater than F critical equal to 5.59. We reject the null. So that's J. We've found that the slope is significantly different from 0. So last few problems here. K. Is there a significant relationship between number of risk factors and achievement? Well, the slope was significantly different from 0, so yes. There is a relationship. That's all you have to put on K. L, if Patricia had 3 risk factors, what would you predict her achievement score to be? So this is for Patricia. We use our regression equation back in letter H. That was 12.37 minus 1.45x, but here Patricia's x is 3. So it's 12.37 minus 3 times 1.45 is 4.35. So 12.37 minus 4.35 is 8.02. So Patricia has 3 risk factors. We predict her achievement score to be an 8.02. Samuel on M. If Samuel had 20 risk factors, what would you predict his achievement score to be? Y bar is equal to, Y hat is equal to 12.37 minus 1.45 times 20. This is equal to 12.37 minus 1.45 times 20 is 29. And so his achievement score, 12.35 minus 12.37 minus 29 is, we predict it to be a negative 16.63. Wow. Can't really happen. Again, present the math the way the math comes out, but practically speaking, if Samuel had 20 risk factors, we predict his achievement score to be 0. That's M. And then N, though, which predicted achievement score, Patricia's or Samuel's, do you have more confidence in, and why? Well, it would be Patricia's, because her X is within the range of the original data set. So her number of risk factors is within the range of the original data set that we used to create the regression equation. Samuel's is not, and so making a prediction based on that many risk factors, Samuel's kind of an outlier, and so we wouldn't have a lot of confidence in predicting his achievement score, but we would with Patricia's, and that's why. Okay, so that's it for the pretest for exam 5. This is the last pretest video we'll do. There is a pretest for the final exam, but because the final exam is optional, I'm not doing, and because no points can be earned from the pretest for the final exam, I think I'll just handle pretest questions on the final exam. I'll handle either in another video where hopefully we could do like a meeting where other students are present, and I could just do sort of an online meeting, FaceTime with those students, and I can answer questions, or students can email me questions off the review sheet, which I will post in Blackboard, and I'll answer those questions via email. Okay, but that's it for this video. So please study hard for exam 5, and I'll see you in class. I'll see you for another video on the final if necessary.